the previous video, we talked about how to find tangent vectors and unit tangent vectors of vector and parametric equations. And now what I want to do is, let's go ahead and find the equation of tangent lines for parametric and vector equations. Okay? So let's say that x is equal to 1 minus t cubed, and y is equal to t squared plus 5t plus 6. Okay? And the first thing that it asks me is find the equation of the tangent line at t equals 2. Keeps on popping up. So equation tangent line t equals 2, I stop, take a deep breath, and make my checklist. My checklist, I need an x1, I need a y1, and I need a slope. Okay. x1 and y1, what I'm going to get, notice how it gives me t equals 2. So let's see what the x value is and the y value is when t is equal to 2. So I'm going to go ahead and plug 2 into my x and my y values. So x1 is going to be 1 minus 2 cubed, which 1 minus 8 is negative 7. Let's plug y1 into there. When I plug 2 into my y, I get 2 squared plus 5 times 2 plus 6, which 4 plus 10 is 14, plus 6 is 20. And now your slope, your m. Let's think about this. Your slope, m, you can also rewrite this as dy over dx, correct? So let's go ahead and literally do dy, the derivative of y, divided by the derivative of x. So the derivative of y, the derivative of my y, is 2t plus 5. And the derivative of my x is negative 3t squared. And now that I have my dy over dx, let's plug our value of 2 into there to find my slope. So when I plug 2 into here, I'm going to have 2 times 2 plus 5 divided by negative 3 times 2 squared, which 4 plus 5, on top that's 9. On bottom here, I'm going to get 4 times negative 3 is negative 12, which I can reduce to negative 3/4. And now that I have my x1, now that I have my y1, now that you have your slope, you plug it into your point slope form. Therefore, final answer, y minus y1, y minus 20, is equal to m, negative 3/4, times x minus x1, which is 7. Okay? And then you can just, of course, do algebra to solve for y. But that's how you would do that. Alright, so same thing. Equation of tangent line, just keep on doing the same thing. Your x1, your y1, your slope. But sometimes you might get a question that looks like this. And it says, when is the tangent line vertical? And when is the tangent line horizontal? Well, the tangent line is going to be vertical. Okay, tangent line is going to be vertical when dx dt is equal to 0. When the derivative of x is 0, that is when my tangent line is vertical. So, the derivative of x is negative 3t squared. I set that equal to 0, solve for t, and t is equal to 0. Therefore, at t equals 0, the tangent line is vertical. And for horizontal, the tangent line is going to be horizontal when dy dt, the derivative of y with respect to t is equal to 0. Okay, so dy dt, the derivative of y, is 2t plus 5. You go ahead and set that equal to 0 and solve for t. And solving for t, t is negative 5/2. Therefore, the tangent line is horizontal when t is negative 5/2.